Photoelectric effect. Before we start, let's understand the structure of metal. In metal, metallic bonds exist in which positively charged atoms are formed, and these atoms lose their valence shell electrons and are arranged in the form of layers. And these layers are arranged orderly upon one another. Now let's understand what is photoelectric effect. When photons of certain energy fall on the surface of metal, they eject the electrons from the layers. According to Planck's theory, this energy of photon is given by relation E is equal to h nu, where nu is the frequency of the incident photon. If you want to learn what are photons, you can watch my previous video. Now let's understand what is photoelectric effect. Can be understood by the simple diagram. We have made metal surface negatively charged, and we have placed a positively charged anode. When the light of certain frequency incident on that metal surface, the electrons are ejected, and these ejected electrons are captured by the detector. These electrons will travel in the circuit, and on the galvanometer we detect the flow of current, and this current is known as photoelectric current. Now let's discuss about the characteristics of photoelectricity. Number one is the total photoelectric current is proportional to the intensity of beam of a particular frequency. Let's understand it with this graph. When we increase the intensity of light, ultimately the photoelectric current increases. Number two is for a particular metal surface, the incident beam of light should have a minimum frequency below which there is no emission of electrons. This minimum frequency is called threshold frequency. If the threshold frequency is not attained, there will be no photoelectric current, whatever the intensity of the incident beam is. If you try to understand this phenomena with the help of this diagram, then we see that the photoelectric current is generated only when the frequency is nu naught. This nu naught is the threshold frequency, and no current will be generated unless this threshold frequency is attained. So it was the second postulate. Number three is the maximum kinetic energy of the emitted electrons for a particular metal plate is completely independent of the intensity of the incident beam. That means the kinetic energy of the electron that are ejected from the metal surface are independent of the intensity of the incident beam, but it depends on the frequency of the incident beam and the nature of the metal. There is something more about the photoelectric current, so keep watching.